2 years ago, I sent my GPS-guided catamaran on a 56-kilometer or 35-mile waypoint mission around Bainbridge Island near Seattle, Washington. The goal was for the boat to complete the mission fully autonomously, without any human intervention. This was no easy task, because it was up against commercial traffic, ferry lanes, debris, choppy conditions, and vast expanses of open water. The boat failed to complete the mission, not because of any of these challenges, but instead because of seaweed. It would get caught up in the propellers really easily, and also my liquid level sensors that controlled the bilge pumps corroded from the salt water, so the boat probably would have sank eventually. So that was a bummer, but it wasn't the only fail that day. When I was launching the chase boat earlier that morning, I forgot to put the drain plug in, and when I got back from parking the trailer, the boat was nearly sank. This big EcoFlow power bank that I had on board was submerged in about 3 inches of salt water. Over the course of the day, I could hear it hissing and popping, and occasionally smoke would come out of it. It was properly ruined. The next day, I pulled all the circuit boards off so that only the battery cells were left. And then for the next 2 years, it sat right here, close enough to my house to burn it down, but still with all the downsides of being outdoors, like moisture and temperature fluctuation. So recently I decided it was time to either do something with it or throw it away. It looks pretty corroded, but after checking the cell voltages with a multimeter, it was clear that quite a few of the cells still had some life left in them. So I figured it would be worth at least trying to harvest some of the 18650s. This thing was pretty difficult to disassemble, but after quite a bit of hunting for hidden screws and Dremel grinding, I was able to get the 2 layers apart.
Yeah.
Then I had to very carefully cut the nickel sheet that each cell was spot welded onto, without cutting too deep and damaging the cell itself. This was pretty tedious work. Unless you know exactly what you're doing, don't try this at home, because short-circuiting this pack or catching the cells on fire would be really bad.
I win!
Eventually I was able to get the cell holders apart.
Woohoo!
After measuring the voltage of each individual cell, I was pleased to discover the majority of them still held their voltage. This means I'd be able to use them for a new autonomous boat, to redeem my failed attempt at circumnavigating Bainbridge Island.
Wow, look at that. That cell almost blew up. This cell is at 3.6 volts too. It's still charged. I can't believe that. So all these cells are good, and all these cells are either bad or they have rust underneath the heat shrink tubing. So I might be able to use a few of these, but they're a little sketchy. So the rusty cells look like this. They seem fine. I don't think the rust affects their performance at all, so I'm just gonna use them.
So next I took all the good cells and carefully ground down all the crap on there to prepare them for spot welding. I also had this big, ancient battery that was made of over 100 18650 cells that were being thrown away at my old job. I previously used it on a solar-powered rover that would drive around the field 24/7 in a figure-8 waypoint mission. I had also used it on the catamaran during my previous Bainbridge Island circumnavigation attempt where it got plenty of salty sea spray, but that didn't seem to matter too much. It was still able to take in 770 watt-hours, so I figured it was at least still worth its weight for our next boat. So now that I knew what batteries I wanted to use, I hopped into Onshape and started to design the hull. Step 1 was to design a cell holder for all the loose 18650 cells. Then after that, I started to design a basic hull around them. I initially wanted to make what was essentially a battery keel, but that keel just kind of grew into the entire boat. I wanted to make this hull really simple and easy to build, but also efficient. So keeping it narrow like this really minimizes the frontal cross-sectional area, so it should glide through the water like a hot dog. And the big pink thing in the middle is insulation foam, so it should have enough buoyancy above the heavy battery keel to stay upright. Fingers crossed, but one thing is for sure, and that is that the batteries are going to be under the water line, so we'll have to make sure they are completely waterproof somehow. If you want to check out this design for yourself, you can access it for free at the Onshape link in the description. Now it's time to start building. Here's the bow. I SLA printed it on the Formlabs Form 4 because resin is heavy, so it will help keep the center of gravity low and make the boat more stable. I also printed several of the hull sections on the Form 4 just to keep the density under the water line up. Here's one of the 18650 holders that will slot into the hull, being printed out of PETG, and this piece here is the rudder and motor mount printed out of Formlabs gray resin. I used these battery spacers to keep the cells at the right height while I spot weld them all together. All the cell holders got some CA on the cracks to temporarily hold them together before they get placed in the hull. And finally, it was time to insert the batteries. So after all the cell slots were full, it was time to start spot welding. Wow, I did a really bad job at counting the number of cells I have. I just took a bunch of cells off those other big bricks, and some of them are pretty suspicious. They have things like 0.6 volts written on them, and hot. They've at least held voltage over the last 2 or 3 years, so I don't think it can hurt. It's probably not going to add a lot of capacity to our pack, but whatever. I bought a cheap spot welder online and it worked well enough. After the top was complete, I of course had to flip it over and do the other side. This pack is 3P, so it will be around 12 volts. I think I welded all the way through the metal on this cell and it started bubbling some liquid, so I gotta replace that one. Luckily I had a couple of spare cells laying around to use as replacements. And that completes the first part of the battery. Hey, it's me, Daniel from the future, and I'm here to tell you about the sponsor of today's video. It just so happens that I am out here next to Bainbridge Island doing the Waypoint mission, but you gotta wait till next episode to see it. If you've seen any of my boat adventure videos in the past, you'll know that I've spent a lot of time alone on the water on very small boats, and it's a lot of fun, but it can also be pretty tough. And honestly, the reason why it's pretty tough is just because you're so isolated. And I'm lucky because this is self-induced isolation. It's not the worst, but a lot of people aren't this lucky, and a lot of people are struggling because the way society is kind of structured today can really tend to isolate people, and it's tough. One of the best ways to deal with such issues is to talk to somebody. And one of the easiest and most convenient ways to talk to a professional trained therapist is through the sponsor of today's video, which is BetterHelp. BetterHelp makes online therapy easier than ever because you can talk to your therapist however you feel comfortable. They do calls, chat, video, and you can even schedule appointments in the future, which makes squeezing therapy into your very busy schedule super easy and doable. Even if you are lucky enough to have a good social support circle, talking to a licensed therapist can be a good idea because they can give you techniques and tips to make positive improvements to your life. BetterHelp's mission is to make starting therapy as easy as possible. If you think you could benefit from chatting with a licensed therapist, click on the link in the description or go to betterhelp.com/rctestflight. Using my link will also get you 10% off of your first month. Now back to the build. Onto the hull. I'm using 5mm carbon rods to align each section, and each section just gets stacked together, one after the other, with Gorilla Glue in between. And here's one of the resin printed sections. And finally the bow. Man, this thing is a hot dog. It's so long. Look how long it is. It touches the roof right there, and then it keeps going all the way over here. After soldering some wire onto the battery, it was time to get greasy. This whole battery is going to be under the water line, and it would be pretty difficult to completely keep it dry. So for that reason, I'm going to pot the whole thing in grease. So I started smearing grease along the whole bottom of the battery, using a card to smear it in as much as possible to hopefully get any air bubbles out. Then I picked up the whole thing, flipped it over, and dropped it into the hull. This thing is starting to get heavy, so I really need to reinforce it before it just breaks apart on me. I probably should have just done this before putting the battery in. This is kind of nice. We can see through the SLA prints to make sure that the batteries are covered in grease. I'm going to add a quick layer of fiberglass to strengthen it. So I first roughed up the surface a bit and then started painting it with epoxy. After that came the fiberglass. I'm just using 6-ounce glass for this, and then I wetted it all out. I ended up doing 2 layers. I then did a layer of peel ply to soak up excess epoxy and improve the surface finish for subsequent layers. I put it all under some black plastic in the sun, and that heated up like an oven to help the epoxy cure. Here's the motor mount and rudder going together. Again, I'm using carbon rods for strength and alignment. To power this boat, I'm using the Blue Robotics M200 motors. These are designed for ROVs and subsea robotics applications, so they should work just fine for our boat. The wires get fed through the rudder, and then the motor just screws in with some M3 screws. I initially had planned to use 2 motors, not because I thought I needed the thrust, but instead because each motor is much more efficient at lower throttle levels. So if we can have 2 motors running at 10% throttle, rather than 1 motor running at 20% throttle, the boat will be more efficient. These are the cells from the old Rover battery that I dismantled, and then I split it in half and put each section end to end so that it will fit in the long skinny hull, and then soldered some wires onto it. After the epoxy on the hull cured, I pulled off the peel ply. That leaves us with a nice matte surface finish for subsequent layers, and now this thing won't break in half when I lift it up. Next, I smeared grease onto the bottom of the battery and dropped it in place. There was a little extra space in the hull, so I quickly welded together a 3S2P2170 pack to take up the space. Now we need something to cover all the batteries, and for that I'm using laser cut acrylic panels. I don't have a laser, so I ordered these parts from Send Cut Send, and just a few days later they showed up at my door. All the panels look excellent. If you want to get laser cut parts made for your own project, use the link in the description for 15% off. They also offer CNC routing, water jet, and a whole bunch more. These panels are going to screw into a lip in the hull to cover the batteries, so I had to tap a bunch of the holes in the resin printed sections. I probably should have just used FDM for all the hull sections to keep it consistent, but whatever, this worked. I also tapped some M6 holes in the acrylic for grease nipples. You'll see why soon. After some countersinking, the panels were ready to go. I tried to fill any open space with foam to waste less grease. That'll make more sense later. I'm using silicone to form a seal between the panels and the rim of the hull, and then all the panels just get secured into place with M3 flathead machine screws. Same story with all the subsequent panels. They get the glue and the screw, but for the FDM sections I'm using thread forming screws instead of machine screws, since I didn't pre-tap the PETG. The clear acrylic is crucial here so we can see what's going on with the batteries as we attempt to waterproof them. My design ended up not matching reality very well, so we're going to have to fix some things. To seal around the main battery wires, I just squirted RTV silicone all up in there. And I also used silicone to seal this grease nipple in. And now it's finally time for the coolest part of this project. I'm going to use my grease gun to pump grease into the entire battery cavity. This was a very time-consuming part of the project because the grease is quite viscous, so it took a lot of time and pressure to pump through. The first step was to obtain the grease. This took a lot of bacon, since our battery cavity is quite large. The cells take up most of the volume, but there's still quite a bit of volume in between the cells and above and below them. The idea behind the grease is that it will fill every single little void and crevice, and if there's no open space left, then there's simply no room for water to enter. This is where it became obvious that I did not use nearly enough screws to hold down the top panels. The high pressure grease was bending the acrylic and coming out the sides. To hopefully fix this, I drilled new holes, drilled again, and then tapped them, and finally put more screws in. This might be a terrible idea, or it might be a great idea, but I've got the vacuum pump connected to this big vacuum chamber. This is going to act like a vacuum capacitor, so I can more precisely control the vacuum in the hole. I'm just going to hot glue this thing onto here and hope that it stays. And then hopefully if I draw just a little bit of vacuum, not enough to make this thing implode, it'll help just enough to pull the grease down without being strong enough to make air flow down. These clear resin prints are kind of brittle, so that's one of the reasons why I poured epoxy in here, is to hopefully prevent the vacuum from just caving them in. Let's see what happens when I open this up. Oh, okay, I see some movement. There's still movement going on even though I'm not pumping. So I think the vacuum sort of works, or helps at least. There must be a little pinhole somewhere in the side because this grease is oozing out very, very slowly. That's why this method is going to be so waterproof, hopefully, because the grease is pressurized, so it's just going to fill all the little tiny holes and voids. Ah, got some oozing again. Damn, I should have put more bolts all the way along this thing. I had a little extra marine grease in this cup, so I ended up just putting it into the grease gun, and that's why you see this kind of green streak going along there. It is slightly lower viscosity. It's starting to ooze out some of these cracks. Speaking of viscosity, I'm going to try using this dimethicone stuff to thin out the silicone grease a bit. Oh yeah, I was just joking about the bacon grease. I'm actually using silicone grease. Lowering the viscosity should allow it to flow through the battery cells at lower pressure, and then hopefully less will ooze out the sides. Once that was well mixed, I loaded it all back in the grease tube and then back into the grease gun and started pumping. Oh yeah, I think the thin stuff is making its way through. Look at that, it's plowing through. So this is mostly an air bubble, but the thinner grease is quickly flowing in to inhabit the space that the air was taking up. The dimethicone oil is mixed mostly with silicone grease, but also a little bit of green marine grease, so that's why it's less transparent than the pure silicone grease. But that's kind of helpful because we can see it flowing through more easily. These clips are obviously a time-lapse. They're at like 3000% speed. But to get the grease to flow like this, I had the vacuum pump on and I was constantly pumping the grease gun by hand. I screwed up the order in which the hull segments were glued together, and for that reason I had to use this little 3D printed piece to bridge a gap. But that seemed to work pretty well and the grease kept flowing. So the vacuum pump reduces the pressure ahead of the grease and that helps pull it through. But it would also suck in a lot of air bubbles behind the grease front. And it seemed like those air bubbles would kind of help push the grease forward, bit by bit. But we won't be able to use the vacuum for the whole time. At the end, we'll have to rely on pressure alone to force the air bubbles out. Because of this, I drilled a lot more holes and added a lot more screws to help contain the pressure. I also started using clamps to hold down the panels where the pressure was highest. And the grease continued its migration. Ugh. Wowee. All said and done, I think the holes took in about 2.5 of these grease tubes. I believe this is our new lower viscosity grease that's coming in hot. This ended up being so much work that I was really wishing I would have just used new battery cells instead of sketchy old ones. But oh well. It's almost like the bubbles from the vacuum would kind of massage the grease down the hull. Kind of cool. It's getting really close to the end, so now I'm going to turn off the vacuum so I can remove that. And I'm hoping that I'll be able to fill up all these vacuum pathways or cavities that have been created just by pumping on the other side. So I think it's going to take a while before the grease gets far enough to start coming out that hole, because there's a lot of voids that need to be filled first. The grease did, for the most part, seem to fill in all the voids as I kept pumping. Of course, it's impossible to actually know without taking it all apart, but from the top it looks pretty solid. I had to kind of purge quite a bit of grease to get those last few air bubbles out, but that's okay. The grease is starting to flow out of the other side, but I gotta keep pumping because there's a few bubbles in there that are slowly working their way to the other side. Once all the bubbles were gone, I stopped pumping and scooped up all the excess grease. All this kind of greenish grease that I put in a while ago is starting to come out. Then I put a grease nipple in on the far side hole to plug it up, and I pulled the grease gun off from the other side. Oh my god, wow, there was a lot of grease pressure on this side. Crap, I probably shouldn't have taken that thing out. So I put that grease nipple back in and pumped some grease in on the far side to restore that sweet, sweet positive pressure, and hopefully fill any remaining cavities on the other side. I ended up alternating back and forth quite a few times, but once I was happy with it, I put both grease nipples back in, gave it a few more pumps, and left it like that. Now the grease is locked in. Now we can finally start on the rest of the boat. I weighed the battery to calculate how much buoyancy we need. Oh, it's only 40. That was way off. To build the upper section of the hull, I'm using XPS insulation foam, and I'm making the upper sections just barely buoyant enough to carry the 40-pound battery. This way it'll ride really low in the water like a narco sub. Just 4 strips of this inch-thick insulation foam will make up the width of the hull, and I had to cut some channels in there for all the battery wires. Then I glued the sheets together to make one big block. Before attaching that to the hull, I first had to sand down any bits of fiberglass or epoxy sticking up from the edges, and I also had to solder an XT30 connector onto all the battery wires. I did not wire the battery cells together in series inside the battery cavity. I basically just have a bunch of 1S battery wires coming out, and I'm going to connect them in series on the top side. That will give me more flexibility in case one cell dies or something like that. I glued on a 3D printed bow extension to give us a nice bow shape, and then the stern is another resin printed part that slots into some alignment rods. And finally, it's time for the foam. I pulled the battery wires through and then taped the foam into place for a quick float test. I sized this block of pink foam to give us a little over 40 pounds of buoyancy so that it would just barely float the batteries and the whole thing would ride really low in the water like a narco sub. This goes to show how good I am at math. I'm zero good at math. I completely failed to account for the displacement of the battery itself. So now we have a very tall narco sub that's definitely going to get apprehended by the federales. Even the propeller on the bottom motor might not even be fully submerged. But the propeller on the top motor is definitely not even going to be underwater, so I got to ditch that motor. I can keep some fish in here. Let's see what's going on down there. Oh no, it's full of water. Just kidding. I don't see any. There's this one little questionable spot right there, where that could be water entering, or it could just be that the lighter colored grease got pulled away as the vacuum was pulling air through there. Since there's so much extra buoyancy, I decided to cut down the foam quite a bit in an attempt to make this boat lower profile. And then I just lightly tacked it in place with hot glue. After that, it was time for another layer of fiberglass. The purpose of this layer is to lock the foam onto the battery section and protect the foam from impact and shark bites. Just kidding, sharks could definitely bite through this. So this was just one layer of 6-ounce glass, and of course I did the same on the other side. This is all just fiberglass left over from my giant 3D printed manned carbon fiber catamaran project that I did last winter. And then after all the glass was laid, I did a layer of peel ply on the surface. And once that cured, I peeled it off. Peeling off the peel ply is always so satisfying. After that, I did a little bit of cleanup with the Dremel, and some light sanding to remove any strings or bumps. I'm really not aiming for a perfect surface finish with this project, not even close. Now it's time for paint. I had some 3-year-old gel coat from my Boston Whaler restoration, and I decided to try it out for this project. I added some sanding aid wax and catalyzer, and mixed it up. The stuff went from being a liquid to a solid over the course of like 20 seconds. It just instantly gooped up, and now my boat looks like this. Not so good. At least the other side looks good. The other side looks great. So yeah, it seems like I over-catalyzed it. I had to sand off the lumps from the unfinished side, but the other side wasn't even curing. But I ended up needing to find some other way to keep oxygen away from the surface so that the polyester gel coat would cure. I tried PVA mold release, but it didn't really work. So then I decided to try pure wax. And I didn't have any wax, so I found some kids walking up from school and took their crayons. Then I started to color my boat with crayons, as an oxygen inhibitor. The wax improved the surface a little bit, and it's super hydrophobic, so I figured it would work just fine as paint. Call me crazy, but I think I might just cover the entire boat in crayons. It feels pretty good. The gel coat on the other side was really thin from sanding, so I gave it a quick layer of primer and then orange spray paint to improve visibility and to reduce the chance of a catastrophic collision. Now it's finally time for the electronics. I'm using an old Pixhawk 2.4.8 running ArduPilot and the RFD900X as both the RC control link and the telemetry link. There's one installed on the back of this transmitter. It's called the RFD TX mod, and that also connects to the computer over Wi-Fi to get the telemetry data into Mission Planner. I'm using this waterproof high-tech servo for steering, and that goes into a 3D printed servo holder. The whole rudder just slots in, and I have a 3D printed control horn on top of that. I've got some nice M3 rod ends on there, and same for the other side. I soldered together this harness to connect all the individual battery cells together, both in parallel and series. Hey, what do you know? No fire. Let's plug this thing into a cell checker and see what it says. Aha, 46%. I've also got a BMS on there to help with balancing and charging. The electronics are going to live in some Tupperwares. The motor is going to be driven by this Blue Robotics ESC. I have all the power electronics in one Tupperware, and then another one for the flight controller and GPS. The radio link is going on the top of this folding mast. I used some insanely long M3 machine screws to screw it directly into the foam, and that felt surprisingly strong. I just glued the RFD 900 to the top of the mast and then taped around it just in case the hot glue melts. And now for the nav lights. I was looking around for something to use and found these old color shadow lamp prototype PCBs that would be just perfect. So I removed them from the heatsink and wrote some Arduino code that pulses them super bright every few seconds. I can't run them at full brightness all the time because that would consume like 30 watts and they would just burn up. But anyways, those just got glued onto the mast. Red on the left, green on the right, and blue on the back. If you're like, what the heck is a color shadow lamp? Then you must have missed my previous video, or at least the last few minutes of it. I unveiled this lamp that I've been working on for the past few years. It has red, green, and blue LEDs, and when all three are shining on a surface, you get white light. But anything that casts a shadow causes the light to get broken up into its colorful components. It's a fun effect to play around with and a great accessory for photography. If you want one, check out the link in the description. After installing the lights, I set up the autopilot. It's running the ArduPilot Rover software. I set the servo endpoints and all that, and then it was off to the lake for the first real test.
And it's moving. Wow, it's actually really fast.
Okay, it actually turns really well. That kind of surprises me. It's so long and narrow that I didn't think it was going to turn very well. And it looks really cool in the water just because of how narrow and tall it is. Man, this thing is awesome. Whoa, look at that bow wave. It's really big. That's not a great sign for efficiency. That's probably just because the bow is not very narrow. It's just kind of blunt. I think it's kind of leaning over from the motor torque. This thing is sick. Okay, I'm going to full throttle. Whoa! Holy crap, it's submarining. Haha! What? Oh, that's hilarious. It's like a snowplow. And now the hull is full of water in the front. When I'm doing the actual autonomous mission, it's not going to be at full throttle ever. On this day, I spent some time tuning the throttle controller and the steering controller, and by the end of it, the PID desired was matching the PID achieved closely enough. And that's what it takes to be able to run waypoint missions with decent accuracy. So it was working pretty well. Oh, it was so close to that buoy. So I just finished tuning the cruise speed and cruise throttle set points. Right now it's doing 1.3 meters per second, and it's doing that pretty comfortably. But I think when we're doing the autonomous mission, I'll try and aim for 1 meter per second. So it's not super fast, but not bad. Yeah, the reason it's kind of leaning over to the side is just from torque from the motor. If we would have been able to have two motors like I initially planned, then we wouldn't have that problem because they would have been counter-rotating, but I don't trust the current sensor on here at all. But from the data we did get, the efficiency curve looks like this. So if I keep the speed at 1 meter per second, then it's going to be so much more efficient than it would be at slightly higher speeds. I think I need to fill the nose with foam. And that's exactly what I did next. This is 2-part expanding polyurethane foam that takes up all the space so that these cavities are no longer just full of water. And I did the same thing to the stern. Can't put any fish in there anymore. Next, I wanted to test this thing out in waves. But there weren't any, so I had to make my own. I set the boat on a waypoint mission that just repeats over and over. So then my job was to go out and try and sink it. Okay, be gone. Okay, let's go chase this boat. Haha! Hey little guy, how's it going? Wow, the rudder is moving a lot. Oh, it looks like it just hit a waypoint. This thing is just a drone, so it's got a flight controller in it with gyroscopes and accelerometers that are correcting the yaw angle hundreds of times per second. So you can see the servo moving to constantly correct and try and hold a set course. Got our little motor under there humming along. See if this thing will pull me. Yes, it will, but not quickly. So we'll see if we can swamp it. What a cool looking boat. Oh. It's definitely getting tossed around quite a bit. Man. Oh, I don't want to hit it. Oh, I just sprayed the camera. Woo. Oh, we just hit a waypoint. Ah. Whoa, I'm down. I turned too sharp. Woo. Oh, that wave broke on top of it. Whoa! It's doing a turn. Ah. Oh, not again. I was trying to hand drag the nose. Got it. Woo! Oh. Woo! Well, I think that's enough torture testing for now. I'm gonna go cruise around a little bit because I think I have plenty of battery here. Sometimes I can see big fish along here. Whoa, there's a turtle. The boat was able to handle everything I was able to throw at it. There was a little bit of water inside the Tupperwares, but I'm gonna make a way for that to drain out later. During this test, everything kept working despite being sprayed by water and hit by pretty big waves. My only concerns are that the speed is pretty slow. At 1 meter per second, it'll take like 15 or 16 hours to complete the whole 35-mile waypoint mission. And also, if we look at the boat from this top-down view, we can see that the steering servo is overcorrecting quite a bit. The fact that it's moving so much means the steering servo will definitely wear out more quickly, so I'd like to tune down the steering a little bit more if possible. But other than that, this boat seemed to be working pretty well. It definitely ended up riding too high in the water to be very useful as a narco sub, so sorry to anyone who wanted to copy this design for global transportation purposes. So that's all for this video. Thanks for watching. Bye.